Alright guys, so here's the section 3.15. Alright, so the thing we're still going to be working on systems, but if you look here, alright, so if you look at this thing, you'll notice that this time when we're looking at these problems, you'll see that these things here, those terms, are exactly the same. Alright? And that's what we want. We want these things to be exactly the same. It doesn't matter if it's the x coordinates or the y the coefficients for the x's or the coefficients for the y. It doesn't matter. We want them to be exactly the same. All right, so you can see they're both 3's. But then the other thing that you notice is one of them is negative, the other one is positive. All right, that's what we want. We want the coefficients. We want them to be exactly the same, but we want the signs to be different. And when that happens, it's so much easier than solving for one of the variables. All right, so it's so much easier than the substitution method. All right, so in this case, it's already set up the way we wanted. All right, like I said, yeah, this is what we wanted. All right, quick reminder, that's what we want. We want the coefficients to be exactly the same, but the variables to be different. All right, when that happens, add straight down. All right, we're going to just be adding straight down. And when you do that, these cancel. And you'll notice that since those cancel, we just add straight down, like I said. And when that happens, we get just a variable by itself. We just end up with y by itself. All right, we don't have to worry about figuring out. We don't have to figure out what x is. All right, we don't have two variables. We have one variable to deal with. All right, so just like always, divide. All right, we end up with y is equal to -6. Now, since we have one of the variables already, all right, we already know what y equals. Pick one of those equations. Pick one of the equations. It doesn't matter which one you pick. All right, it doesn't matter which one you pick. You're gonna plug this -6 in to one of those two equations. So you can either plug it into the first one or to the second one. It doesn't matter. All right, I'm gonna pick that one right there. I'm gonna pick equation number 2, just because the numbers are smaller and I'm lazy. All right, so I have 3x plus 4 times -6. Again, remember, I'm replacing y with -6. We already solved for it. Is equal to -15. Now, just like always, all right, we're going to solve for x. All right, add that 24 to both sides. All right, adding the 24 to both sides. That cancels, so 3x is equal to -15 plus 24 gives me 9. Divide both sides by 3. X equals 3. All right, so now we have our solution. We have our solution. So our solution is 3, -6. Don't screw this up. All right, just because we solved for y first, remember, y is always the second variable. All right, don't screw it up. Okay, now let's look at number 2. All right, looking at number 2, what do you notice here? Well, just like I mentioned the first time, we're looking at the coefficients. Well, I look at the x's, they're not the same. Well, then I go over here and I look at the y's. Those are the same. And as a bonus, the the signs are different. All right. So let me erase all this mess. Because the y are the same. All right. Because the y's are the same, and the coefficients have different signs. In this case, now we add straight down. All right. We're still adding straight down. Those y's cancel, and this time we're going to be solving. We'll be solving for x. All right. So 8 plus 17 gives me 25x is equal to And 114 plus 261 gives me 375. Divide both sides by 25. X is equal to 15. All right. And again, pick one of those pick one of those equations. All right. Pick one of the equations. Sometimes I'll refer to it as just, I'll do like this: equation 1, and then here's equation 2, just so we know which ones we're talking about. All right. Again, you could plug in X for either one of those equations. I'm lazy. I'm going to pick the smaller numbers. So I'm going to plug it into equation 1. All right. So I'm going to pick equation 1. All right. 8 times 15 minus 12y is equal to 114. And by this time, you should already know how to solve. All right. So I'm going to just speed things up a little bit here. All right. You know what? This part I'm not going to skip because I don't want anybody screwing this up. Divide both sides by negative 12. All right. The answer is not 2. You'll notice that the bigger number is on the bottom. Since the bigger number is on the bottom, it's going to stay a fraction. I can divide both of these by, well, in this case, actually negative 6. All right. I can divide both of them by negative 6. So we end up with 1/2. All right. So our solution is 15 1/2. Or you could put 0.5. I really don't care. All right. Now, let's look over here at B. All right. So here I have equation 1. Here's equation 2. All right. And what are you noticing? All right. What are you noticing with these two? Let me just get that out the way. What are you noticing with equation 1 and equation 2? Well, if I look at the variables, are those the same? Nope. Are those the same? Nope. All right, so here we got a little bit of, oh, come on, eraser. All right, sorry about that. Here we have a little bit more work ahead of us. All right, so those first two that we did, we were able to just add right away. But can I multiply one of those equations by something so that I get the other number? Well, let's look at this. What happens if I multiply that by 4? Do you agree? Do you agree that it'll give me that 8? All right. Do you agree that it'll give me that 8 if I multiply that top one by 4? Yes. All right. So what I'm going to do is I'm going to multiply this top one by 4. I'm not going to multiply by negative 4. I want the signs to be different. All right. I want those signs to be different. So if I multiply by negative, it's going to screw me up. I want it to stay positive in this case. So I'm going to multiply everything, every one of these terms, I'm going to multiply by 4. All right. I can't just multiply one of them. I have to multiply all of them. So I end up with 8x plus 16y is equal to whatever negative 46 times 4 is. What was that? Negative 184. All right. So I multiply everything by 4. And then this other one, do I need to multiply by anything? Nope. I'm going to leave it alone. So I'm just going to drag that one across. All right. Just dragging across. And when you do that, when you do this, you'll notice these are going to cancel. And I end up with 19y, right? And then negative 184 plus 51 gives me negative 133. Now divide both sides. Divide both sides by 19. So y is equal to negative 7. Now again, you pick which one of these equations you want to put it into equation 1, or do you want to put it into equation 2? It doesn't matter which one you put it into. All right? Doesn't matter. All right, so what if we pick equation, I don't know, let's just pick equation 1. It doesn't matter. So 2x plus 4 times negative 7 is equal to negative 46. 2x minus 28, negative 46. All right, have to add that 28 to both sides. All right, so we end up with negative 18, and divide both sides, we end up with negative 9. All right, so negative 9, negative 7. Now, this entire time, when you do this, you should be checking your answers. Right? You guys remember how to check the answers? Oh my God, I don't know if I have enough room anywhere. All right, let's see. How about we squeeze in right here? I'll change the color. And how about I squeeze in right here? I'm not going to do the entire problem for you, but you guys do this mess. All right, so equation 1, 2 times negative 9 plus 4 times negative 7. That better equal negative 46. Grab your calculators, figure it out. All right, it better equal. So you better have negative 46 is equal to negative 46. If these two sides are different, you messed up. You better go back and check your work. All right, and then the other one, negative 8 times negative 9 plus 3 times negative 7 is equal to 51. It better equal. So you better end up with 51 equals 51. If not, you screwed up. Go back and check. All right, but I'm not going to do the work for you. You guys do it. All right, last one here. All right, so we solve this system. We solve this system here 3 different ways. And when we do it 3 different ways, the answer better be the same every single time. All right, so we're going to do it one time. One time we're going to do it by graphing. All right, so when we graph, that means we have to get y by itself. Then we're going to do substitution. All right, we'll do the substitution method, and that was what we did in that last video. And then we'll do the elimination method. Okay, so I'll remind you guys how to do the substitution and the graphing. All right, in order to graph, what do we have to do? We have to get y by itself for each one of these equations. For each one of these, we have to get y by itself. All right, so I'm going to look at equation 1. All right, so here's equation 1. 3x is equal to 2y minus 8. Well, again, remember, what am I solving for? I'm solving for y. So what do I have to do? Add 8 to both sides. So I end up with 2y is equal to 3x plus 8. I'm trying to put it in slope-intercept form. Now divide everything by 2. So I have y is equal to 3 over 2x plus 4. If it's screwing you up because y is on the other side, switch everything. All right, it's not that big a deal. All right, we just switched everything. Now let's look at equation number 2. X minus y is equal to negative 2. We're solving for y. But what do we have to remember? There's a negative in front of y. All right, don't screw that up. So I'm going to subtract x from both sides. Negative y. All right, don't forget to drag that negative down. Is equal to negative x minus 2. And how do I get rid of that negative? Well, if you guys think about it, there's actually just a negative 1 sitting in front. So I'm going to divide everything by negative 1. Y is equal to x plus 2. All right. So my slope here for equation 1, my slope is 3 over 2. My y-intercept is 4. Equation 2, my slope is 1 over 1. Right? I always write it as a fraction. Remember, rise over run. And then my y-intercept is 2. Okay. Now I apologize because I can't draw straight lines on this tablet here. All right. So you guys can do a better job of this, but you'll get the idea. So with equation 1, with equation 1, I'm starting at 4. All right. Remember, I always start with the y-intercept. Always start with the y-intercept. So I'm starting at 4. And then, what does the slope tell me to do? It tells me go up 3 to the right 2. Up 3 to the right 2. So 1, 2, 3 over 2. And I keep going. Okay. Now, could I actually go the opposite way? Yes, I could go the opposite way also, because you'll see that line is forming. Right? You'll see their line forming there. So I can go down 3 spaces to the left 2. Well, going down and to the left, down is negative, to the left is negative. A negative divided by a negative still gives me a positive. All right. So again, guys, I apologize, I can't draw a straight line. I didn't do too bad there. Let me see. Kind of missed there. Okay, but you guys get the idea. There's my line. Now, equation 2. Where am I starting? I'm starting at 2, the y-intercept. Start at 2 right there. Now what am I going to do? I'm going to go up 1 to the right 1, up 1 to the right 1. Well, you can see that I'm moving away from that other line. So if I go down 1 to the left 1, down 1, all right, and keep doing that, oh, eventually what happens here is where they're going to cross. Since I can't draw a straight line on here, not perfectly straight line, guys. All right, I know that sucked. I'm sorry. All right. So what is my solution? The solution when we graphed was -4. All right. All right. How can I do this here? -4. All right. I'm just going up to -4, and then -2. Again, how could I verify this? How could I verify that that answer is correct? I can take these two answers, this -4 and -2, and plug it back into the equations. I'm going to let you do it. I'm not doing that mess. All right, substitution. All right, then. So for substitution, let me rewrite the problems. All right, let me rewrite them, the original problems here, which was 3x is equal to 2y minus 8. And then the other equation was x minus y is equal to -2. Now, I could go through and solve this equation 1. All right, here's equation 1, there's equation 2. I could solve equation 1 for x and then take that answer, whatever we have left, and plug it in over here for equation 2. But I'm going to show you guys, let's cheat a little bit. All right? Do you agree that we already solved for y there, and we already solved for y in equation 2? Do you agree that we already solved for y in both of those? Okay? Since we already did part of the substitution. I don't want to go back and do extra work, so I'm not going to solve for that x. I'm not going to solve for that x again. Right? I'm not going to solve for the x. I already solved for y. I already solved for y. So I know this equation, y is equal to 3 over 2x plus 4. I know this equation, y is equal to x plus 2. All right? Now, the thing I wanted to show you guys is since I solved both of these equations for y, all right, since both of those equations were already solved for y, what I'm going to do is I'm going to take all that mess and set it equal to that. Because since y's are exactly the same, I'm just going to put 3 over 2x plus 4 is equal to x plus 2. Because y has to equal exactly the same, right? Y has to be the same. So whatever y equals in one, I'm going to force it to equal what y equals in the other one. All right. So let's make this a little bit easier on ourselves. What if we subtract 4 from both sides? So I end up with 3 over 2x is equal to x minus 2. And now, let's multiply everything by 2. Why am I doing that? in an equation, how do I get rid of fractions? Multiply by the denominator. All right, common denominator here. So I'm left with 3x is equal to, now I'm going to distribute, holy cow, I don't know what just happened there, guys. All right, so now what am I going to do is I'm going to distribute, all right, distribute. So 2x minus 4. And now this problem is so much easier once we got rid of the fraction. Subtract 2x from both sides. So I have x is equal to negative 4. Now how do I figure out what y equals? All right, how am I going to figure out? Let me get rid of all this. Oh, sorry, I keep erasing stuff that I shouldn't. All right, what am I going to do here? I'm going to take x equals negative 4 and plug it into one of these two equations for x. Well, which one do you think looks easiest? Equation 2. Y is equal to negative 4. I'm just replacing x with negative 4 plus 2. So y is equal to positive 2. Well, oops, sorry. If I can learn to add, negative 4 plus 2 is negative 2. All right, so what's my solution? Negative 4, negative 2. Well, do you agree it's the same? All right, it's the same as over here. All right, it's the same. So far, so good. All right, negative 4, negative 2. It's exactly the same. Now the elimination. Elimination. The way they wrote it for us is a little kind of messed up. All right, so let me rewrite them again. The way they wrote it for us, 3x is equal to 2y minus 8, and then x minus y is equal to negative 2. For elimination, it's a little bit messed up because you'll notice over here with equation 1, there's equation 1, there's equation 2. I want to keep labeling it so you guys know what the hell I'm talking about. If you look at equation 1, you'll notice that the y term is on the right side of the equation. All right, we want it on the left side. We want it on the left side. So how do I move that 2y to the other side? I'm going to subtract 2y from both sides. All right, so I end up with 3x minus 2y is equal to negative 8. Now it's in standard form. All right, x and y are both on the left side. If you look at equation 2, it's already like that. It already was set up for elimination. All right, it was set up with the standard form. All right, so let's rewrite this. Let me rewrite it in black so that we know that it's the original. And then I have x minus y is equal to negative 2. All right, so there's the originals now set up for elimination method. All right, standard form, x's and y's are both on the left side. The constant is on the right side, the number that's by itself. X's are lined up, y's are lined up. Now, what can we do? Well, I can multiply either one of these equations. All right. Remember, what do I want to happen? I want after I finish multiplying, I want that to cancel or that to cancel. One of those I want to cancel, not both of them, just one. All right. So you decide. You can multiply by whatever you want. You can cancel any term you want. Do you want to cancel the x's first? Do you want to cancel the y's first? All right. Since you guys are not here to ask, I'm going to multiply the denominator. I'm sorry. I'm going to multiply equation 2. All right, the bottom equation. I'm going to multiply that by negative 3. What happens when I multiply by negative 3? What's going to cancel? The x's will cancel. All right, the x's will cancel. So this first equation, I ain't doing anything to it except for dragging it along. And then I'm going to multiply everything. Equation 2, I'm multiplying everything by negative 3. So negative 3x plus 3y is equal to positive 6. Now I add straight down, and just like we said was going to happen, all right, the coefficients are exactly the same, and the signs are different, okay? Exactly what we want to have happen. That cancels. negative 2y plus 3y, positive y. Negative 8 plus 6, negative 2. And then pick one of those two equations. All right, go back to the original. Pick one of those two equations. Doesn't matter which one you pick. I'm going to pick equation 2. So I have x minus. I'm replacing y with negative 2. All right. And what happens when you have two negatives next to each other? All right. Please don't mess that up. So we end up with x plus 2 is equal to negative 2. Subtract 2 from both sides. X is equal to negative 4. Well, what have we had every single time? All right. Every single time. Change the color. Every single time. Negative 4, negative 2. My solution, negative 4, negative 2. Even when we graphed, negative 4, negative 2. All right? Hopefully that helps.